The Amish community has long been admired for their ability to preserve food that remains fresh and nutritious for years, sometimes even decades. Their techniques not only extend the life of food, but also maintain its flavor and nutritional value. In this video, we'll explore the traditional methods the Amish use to make their food last so long, often without refrigeration, and how these approaches continue to prove effective in the modern world. Number 1. Canning for long-term preservation. Canning is a versatile and highly effective method for preserving food over the long term, allowing it to last for years without refrigeration. The process involves placing food into sterilized glass jars and sealing them under heat to create a vacuum, which prevents the growth of bacteria, molds, and yeasts. One of the key elements that makes canning so successful is the vacuum seal that forms as the food cools. This seal keeps air and other contaminants out, creating a stable, oxygen-free environment that prevents spoilage. There are two primary types of canning: water bath canning and pressure canning. Water bath canning is typically used for high-acid foods like fruits, tomatoes, pickles, and jams. The high acidity of these foods helps prevent the growth of harmful microorganisms, making this method safe and effective. In this process, jars filled with food are submerged in boiling water, which heats the contents to the necessary temperature to kill bacteria and other potential contaminants. The boiling temperature in a water bath, 212 degrees Fahrenheit or 100 degrees Celsius, is sufficient for these high-acid foods, but isn't enough to safely preserve low-acid foods. For low-acid foods like vegetables, meats, and soups, pressure canning is required. Low-acid foods must reach a higher temperature, 240 degrees Fahrenheit or 116 degrees Celsius, to eliminate harmful pathogens like Clostridium botulinum, the bacteria that cause botulism, a potentially fatal foodborne illness. Pressure canners use steam under pressure to raise the internal temperature of the jars to this critical level. Unlike water bath canning, pressure canning ensures that even the most heat-resistant bacteria are destroyed. A crucial aspect of canning is the preparation of the food. Before placing it in jars, it must be cleaned, peeled if necessary, and possibly blanched to destroy enzymes that could lead to spoilage. Additionally, sterilizing the jars and lids is essential to prevent any contamination before sealing the food inside. After filling the jars, leaving enough headspace between the food and the lid is important. This headspace allows for the expansion of the food during the heating process and ensures a proper vacuum seal once the jars cool. The method of cooling after processing is another critical step. Once the jars are removed from the canner, they must be allowed to cool at room temperature, undisturbed, to ensure that the vacuum seal forms correctly. A well-sealed jar will have a concave lid, indicating that the vacuum has formed. If the seal is compromised, it can allow air and bacteria to enter, rendering the food unsafe for consumption. Canning also extends beyond simple preservation. By carefully selecting and processing foods, individuals can ensure they maintain the maximum nutritional value, flavor, and texture of the food. For instance, canning tomatoes at their peak ripeness ensures that the nutrients and flavors are preserved at their best. Additionally, certain foods, such as sauces, soups, and stews, can be canned in ready-to-eat portions, making them convenient for later use. Another less discussed benefit of canning is its role in reducing food waste and supporting sustainability. Many people can excess produce from their gardens or buy bulk produce in season to preserve for the winter months. This helps reduce reliance on commercial food systems and lowers overall waste. In today's world, where food waste is a significant issue, canning provides a way to preserve food that might otherwise spoil. Number 2, the art of fermentation. Fermentation is an ancient technique that transforms food through the action of beneficial microorganisms, typically bacteria and yeasts. This process preserves food by converting sugars into acids, gases, or alcohol, creating an environment where harmful pathogens cannot survive. One of the most important outcomes of fermentation is the creation of lactic acid in foods like sauerkraut, pickles, and yogurt. Lactic acid lowers the pH of the food, making it too acidic for harmful bacteria to grow, thus ensuring long-term preservation without refrigeration. In the Amish community, fermentation is often used to preserve vegetables such as cabbage, cucumbers, and beets, which are transformed into sauerkraut, pickles, and other fermented goods. This process is not only about preservation, but also about enhancing the food's nutritional profile. Fermented foods are rich in probiotics, which are live bacteria beneficial to gut health. These probiotics can improve digestion, boost immunity, and even enhance the absorption of certain nutrients. Therefore, fermentation provides both a means of preserving food and increasing its health benefits. One of the keys to successful fermentation is maintaining the right conditions. Temperature plays a critical role. Most fermentations occur best at room temperature, around 60 to 70 degrees Fahrenheit, 15 to 21 degrees Celsius. Too cold, and the fermentation slows down significantly. Too hot, and the beneficial bacteria can die or be overtaken by undesirable organisms. Salt is also a vital element in fermentation, as it creates an environment that encourages the growth of beneficial bacteria while inhibiting the growth of harmful ones. Salt also draws moisture out of the vegetables, creating a brine that prevents spoilage. The containers used for fermentation are equally important. The Amish traditionally use glass jars or ceramic crocks, which are non-reactive materials that do not interfere with the fermentation process. Ensuring that the food stays submerged in its brine is critical because exposure to air can lead to mold and spoilage. Weights are often used to keep the food below the brine, ensuring that anaerobic conditions are maintained. In the case of sauerkraut, shredded cabbage is packed tightly into containers, and the natural juices released through salting form the brine. Fermentation takes anywhere from a few days to several weeks, depending on the type of food, temperature, and desired flavor. Fermentation also has the added benefit of intensifying flavors. As the food ferments, it develops complex, tangy flavors that are often more pronounced than in fresh produce. This is why fermented foods like kimchi or sauerkraut are valued not only for their preservation qualities, but also for their bold taste. These foods become integral parts of meals, adding a burst of acidity and depth to dishes. Fermentation is not only practical, but also sustainable, as it requires no electricity or complex equipment. It allows the preservation of harvests without modern refrigeration, which is crucial in off-grid living scenarios like those of the Amish. This low-energy method of food storage, combined with its nutritional enhancements and flavor development, makes fermentation a highly valuable technique in long-term food preservation strategies. Number 3, dehydration and drying techniques. Dehydration is one of the oldest and most effective methods for preserving food, and it plays a crucial role in long-term food storage, especially in off-grid communities like the Amish. The principle behind dehydration is simple. Removing moisture from food inhibits the growth of bacteria, yeast, and mold, which need water to thrive. By lowering the moisture content of food to below 10%, it becomes lightweight, easy to store, and can last for months or even years without refrigeration. The Amish traditionally used both natural air drying and modern dehydrators. Sun drying is one of the oldest forms of dehydration, where foods like fruits and herbs are laid out in a clean, ventilated area with direct sunlight. This method works well in climates that are warm, dry, and sunny. However, To protect the food from dust and insects, the Amish may cover the produce with fine mesh screens. Air drying is often used for herbs, beans, and certain fruits like apples, which can be strung together and hung in a warm, dry area, such as a barn or attic. These methods are energy efficient and sustainable, making them ideal for communities without reliance on electricity. For more control over the drying process, Amish families may also use solar dehydrators or simple electric dehydrators when off-grid power sources like generators or solar panels are available. Dehydrators work by circulating warm air around food, speeding up the drying process while maintaining consistent temperature and airflow. These devices allow for dehydrating a wide range of foods, from vegetables to meats. Dehydrators typically operate at temperatures between 120 degrees Fahrenheit and 160 degrees Fahrenheit, 49 degrees Celsius to 71 degrees Celsius, ensuring that foods dry thoroughly without cooking them. A critical factor in successful dehydration is the preparation of the food. Fruits and vegetables must be sliced thinly and evenly to allow for consistent drying. In some cases, pre-treating food with citric acid or blanching it briefly in boiling water can help preserve its color, texture, and nutrients during the dehydration process. For example, blanching vegetables like carrots or green beans before dehydrating helps maintain their vibrant color and crisp texture, which would otherwise degrade over time. Similarly, fruits like apples or peaches benefit from being dipped in lemon juice or a citric acid solution to prevent browning. The Amish also dehydrate meats, creating a version of jerky that is a protein-rich, shelf-stable food source. To make jerky, meat must be sliced thinly, marinated in a salt solution, or seasoned with herbs and spices, and then dehydrated at a low temperature until it becomes firm and dry. Meat that is properly dehydrated can last for many months when stored in airtight containers, and it provides a nutritious and convenient food option, particularly for long winters or when refrigeration isn't available. Once dehydrated, foods should be stored in airtight containers, such as glass jars or vacuum-sealed bags, to protect them from moisture and pests. Oxygen absorbers can also be added to containers to help extend the shelf life by reducing the oxygen levels inside. The ideal storage environment for dehydrated foods is cool, dark, and dry, as heat and light can degrade both the flavor and the nutritional content of the preserved food over time. The process of dehydration also concentrates the flavors of the food, making dried fruits like apples, peaches, and berries sweeter and more intense. This makes them not only a practical option for long-term storage, but also a tasty addition to meals and snacks. Vegetables and herbs, once dried, can be rehydrated later by soaking them in water, restoring much of their original texture and flavor, while dried meats like jerky are ready to eat as is, making them ideal for travel or emergencies. Number 4. Root cellaring and natural cold storage. Root cellaring is a highly effective method of natural cold storage that relies on the Earth's stable temperature and humidity levels to preserve fruits, vegetables, and even some meats over extended periods. This technique requires no electricity, making it ideal for off-grid living and self-sufficient communities like the Amish. Root cellars are typically built underground or partially below ground, as the earth provides natural insulation to maintain a cool, stable temperature throughout the year. The key to successful root cellaring lies in controlling 3 main factors: temperature, humidity, and ventilation. The optimal temperature for most root crops is between 32 degrees Fahrenheit and 40 degrees Fahrenheit, 0 degrees Celsius to 4 degrees Celsius. This cool environment slows down the biological processes that cause food to decay, such as respiration and enzymatic activity. However, different types of vegetables have varying temperature needs. For example, Potatoes and carrots store best at around 40 degrees Fahrenheit, while apples prefer slightly cooler temperatures around 32 degrees Fahrenheit. This variability means that a well-designed root cellar may have separate zones or shelves for different types of produce. Humidity is another critical factor. A relative humidity of 85% to 95% is ideal for storing root vegetables, as it prevents them from drying out. If the humidity is too low, vegetables like carrots, beets, and turnips can become shriveled and lose their texture. To maintain high humidity, some root cellar designs include dirt floors, which naturally help retain moisture. Adding trays of water or damp sand can also help create the right conditions. However, too much moisture can lead to mold growth, so proper ventilation is equally important. Ventilation is crucial to regulate both temperature and humidity. Fresh air prevents the buildup of ethylene gas, which some fruits, like apples, produce naturally and which can cause nearby vegetables to spoil faster. Root cellars often include air vents or pipes that allow for natural airflow, drawing in cool air from outside and allowing warm air to escape. This airflow is essential during warmer months, but during colder periods, vents may need to be partially blocked to avoid freezing the produce. The types of food stored in a root cellar are generally hardy crops that can tolerate cooler temperatures. Root vegetables like potatoes, carrots, beets, and parsnips are the most common choices, as they can last for months under the right conditions. Apples, cabbages, and onions are also good candidates for long-term storage, though they require slightly different conditions. Apples, for instance, should not be stored too close to potatoes, as the ethylene gas emitted by apples can cause the potatoes to sprout. Proper preparation of the produce before storage is essential to ensure longevity. Vegetables should be harvested at their peak maturity and allowed to cure for a short period before being placed in the root cellar. For example, potatoes and onions benefit from curing in a warm, dry environment for 1 to 2 weeks to toughen their skins, making them less susceptible to spoilage. Vegetables should also be free of damage or bruises, as even minor injuries can lead to rot, which can spread to other stored items. Using containers like crates, bins, or baskets made from breathable materials such as wood or mesh helps to keep the produce well aerated. Some root cellars also employ layers of damp sand or sawdust to insulate vegetables like carrots and parsnips, which helps them maintain moisture and freshness. Shelving and storage areas should be organized to allow easy inspection of the produce, enabling users to quickly identify and remove any items that may be beginning to spoil. Number 5, the power of salt and curing meats. Salt has been used for centuries as a powerful preservative, especially for curing meats. The process works by drawing moisture out of the meat, creating an environment where harmful bacteria, such as those responsible for spoilage and botulism, cannot survive. Salt not only dehydrates the meat, but also alters the protein structure, making it more resistant to microbial growth. This method is particularly effective for long-term preservation without refrigeration. There are 2 primary techniques for curing meats with salt: dry curing and wet curing, also known as brining. Dry curing involves rubbing salt and sometimes sugar or spices directly onto the meat. The meat is then left to rest in a cool environment, allowing the salt to penetrate deeply. This technique is common for preparing products like prosciutto, bacon, and pancetta. Wet curing, on the other hand, involves submerging the meat in a saltwater brine. This method is often used for preserving ham, corned beef, and fish. The salt solution allows for even curing, ensuring that the entire cut of meat is preserved and flavorful. The addition of nitrates or nitrites in curing is also significant, as these compounds help prevent the growth of harmful bacteria like Clostridium botulinum. Nitrites give cured meats their characteristic pink color and enhance the flavor. Properly cured meats can be stored for months or even years when kept in a cool, dry place, making this method invaluable for off-grid communities or those seeking to maintain a stable food supply without relying on modern refrigeration. Number 6. Timeless preservation techniques with modern benefits. Timeless preservation techniques such as fermentation, drying, and canning have been used for centuries to keep food safe and nutritious without the need for modern refrigeration. These methods have evolved with time, but their core principles remain rooted in nature's own preservation systems. The key benefit of these age-old techniques lies in their simplicity and sustainability, which modern technology now enhances to make them more efficient and safer than ever. Fermentation, for example, once relied solely on environmental bacteria to preserve food. Now, controlled strains of bacteria can be introduced to ensure consistent and reliable results, improving the safety and nutritional quality of fermented foods like sauerkraut and kimchi. Similarly, canning techniques, traditionally done over open fires, have been refined with pressure canners and temperature monitoring, ensuring that harmful pathogens like botulism are eliminated. This blending of old and new allows for a safer process without losing the richness of the original preservation methods. Drying techniques, once dependent on the sun and air, have also benefited from modern dehydrators. These tools allow for precise temperature control, ensuring optimal preservation of vitamins, minerals, and flavor. Yet, even with these technological advancements, the energy efficiency and minimal resource needs of these methods make them highly sustainable in today's world, perfectly aligning with modern values of reducing waste and conserving energy.